And we are starting chapter 2 here. The first section is on finding square roots and comparing real numbers. This is the first part of a two-part video series. Looking here at these tables here. I've got a table of squares. So let's say we're going to fill in here values of n. Let's say we've got 0, 1, 2, 3, 4, and it can keep going. We're just going to look at this, focus on these few numbers here. And we take the square, well, 0 squared, 0 times 0 is 0. If we take 1 squared, 1 times 1 is 1. If we take 2 squared, 2 times 2 is 4. If we take 3 squared, 3 times 3 is 9. And if we take 4 squared, 4 times 4 is 16. Over here, if we look at some things here, if we've got, say we've got the square root of 1. Well, when we take the square root of something, we're looking for what number times itself gives you that. Well, you can do 1 times 1 is 1. So the square root of 1 is 1. And it's plus or minus because, well, if you take a positive 1 and multiply it by a positive 1, you get positive 1. But if you also take a negative 1 and multiply it by negative 1, you also still get a positive 1. So there are two possible answers for that. If we take the square root of 4, well, that's going to be plus or minus 2. If we take the square root of 9, that's plus or minus 3. And if we look for a pattern here, we got plus or minus 4, plus or minus 5. Well, this is going to be 16 because 4 times 4 is 16, 5 times 5 is 25. So these are a table of square roots. These are all perfect, what we call perfect squares. Down here in the question is, well, what's a perfect square? Well, a perfect square is when you can take the square root of a number and get an integer. So like the square root of 4 is plus or minus 2. Okay, so those are perfect squares. We also call these not only perfect squares, but rational numbers. Okay. So what is a perfect square? We can say it's the when you get this when you get an integer as the square root. When you get an integer as a square root. Okay, and these are all, like I said, rational numbers. If we look at this here, this symbol right here is what we call the radical symbol. Anything inside of the radical symbol is what we call the radicand. Alright, so we want to find these square roots here. Looking at this one here, 49, we want to know what times itself is 49. Well, 7 times 7 is 49, and it says plus or minus here, so we're going to have the final answer for that's going to be plus or minus 7. Now this one here doesn't have any symbol, so we look at this as a positive answer. Square root of 36, well, 6 times 6 is 36. And here, we want to find the square root of 81. Well, 9 times 9 is 81. There's a negative sign out here indicating that we want the negative answer there. So if you see the plus or minus, you want both those answers. If there's no symbol, we assume that it's positive, and if you see the negative symbol there, that means we want the negative version of the square root. Alright, for approximating square roots. 34. Well, I'm just going to make a list over here of the perfect squares that we've got, and I'm just going to put 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, if we were to do the square root of 1, we get that. Square root of 4, we get that. Square root of 9, we get that. Square root of 16 would give us 4. Square root of 25 gives us 5. Square root of 36 gives us 6. Square root of 49 gives us 7. Square root of 64 gives us 8. That looks like a 69. Let me change that real quick. So square root of 64 gives us 8, and square root of 81 gives us 9. So with the square root of 34, I'm going to look at what two perfect squares it's in between. And if we look over here, 34 would fall in here, in between the square root of 25 and the square root of 36. So I'm going to write the square root of 25, square root of 36. The square root of 34 goes in between there. Okay. Well, we know this is 5, and we know this is 6. So the square root of 34 is going to be between 5 and 6. I'm going to put a little symbol here like this that means approximately. So I know it's 5 point something. Then what I'm going to do is look at how far it is from there to there. Well, that's a distance of 2. And how far it is from here to here, which is 9. As I look at this, well, the square root of 34 is much closer to the square root of 36 than the square root of 25, so that the square root of 34 is going to be closer to 6 than it is 5. So I would approximate this might be 5.8. So I'm going to approximate the square root of 34 at 5.8. Okay. Now if we look at this one, we want the negative sign here out means we want to find the negative answer of it. So square root of 72, if I look at this list of perfect squares, 72 falls in between the square root of 64 and the square root of 81. So I'm going to put the square root of 64, and we're doing the negative versions, and the square root of 81. And the square root of 72 falls in between there. Let me fix that real quick. Alright, so square root of 72. Now I'm going to look to see how far it is from one to the other. Well, from here to here is 9, and then from here to there is 8. Well, going back to this is going to be negative 8. Square root of negative 8, square root of 81 is 9. Again, we're going to approximate. We know it's in between 8 and 9. It's almost in the middle, but it's closer to the square root of 64 than it is the square root of 81. So I'm going to say it's a little less than halfway, so I might estimate that at negative 8.4 or 8.5 since it's almost in the middle. So I'm approximating this at negative 8.4.